So I wanted to kick things off a little bit with some of my personal explorations, and then I'll hand it over to the actual expert, Damien, who actually will be where is Damien? Okay, yeah, who actually be showing how it works under the hood. So if some of you have tried this, did anyone try calling this? I put this up briefly. How was the experience? What did anyone have an interesting experience?
It told me a pretty fun joke.
It told you a fun joke. Okay, nice. I mean, it basically gives you back whatever you want from it.
It was a lot quicker.
So you said it was a lot quicker than you thought it would be. Yeah.
I was wondering if is it a number I can call?
Is it a number you can call from Joe? Sure. I don't know if you have like one phone call you want to call an AI, but whatever floats your boat. I don't know. So we're gonna make this live. Yeah. It's kind of fun. So I was just messing around with Vappy. It's one of these like YC startups. There's like 5 of these. So don't particularly create this as like an endorsement, but they are very, very easy to work with. So I would definitely endorse that. Sorry. Yeah, VAPI. I think it's like voice API. And so we're just gonna create a personal AI. I think I can just kind of create like a blank template. And we can just call this like, I don't know, latent.space pod. I don't know. Latent space. It doesn't actually matter. And we can do like a system prompt, right? Like you answer in pirates speak something. And then we can publish. And then we can start calling it. I don't know if the voice actually was, oh, by the way, we have no volume control on this thing. So it's going to come over the speakers really loudly, and we cannot control that, but it'll be short. For some reason, it's not connecting. Oh, it wants to use my microphone. Hello. All right, let's try calling it again. Is this working? Is this on? Hello. Hey.
Aye, 'tis working, matey. Your voice be echoing through loud and clear. What can this old sea dog do for you today?
Oh my God. Can you tell us how to turn down the volume in AWS Lofts?
Or if you be wanting to adjust the volume in OSLex, you'll be in a bit of a pickle, for OSLex itself doesn't have a volume control.
Okay, yeah, anyway, that was it. So you can I thought this was a super nice experience. Like you set up a voice thing, you can connect a phone number to it if you buy a phone number. That's the experience that you saw if you call this number. And you can customize it however you like, whatever system message you have. On my live stream that I did last week, I added memory to this thing. So if you call it back, ideally you should just remember the previous conversation you have, and then you have a personal AI. It didn't take that long. I just did it one-handed. Yeah, it's pretty great. It's actually built today. I discovered it's built on Deepgram, which is Damien's next talk. So I'll hand it over to Damien while he comes over and sets up. But yeah, welcome to Damien. Oh, and then Igor, if you want to come up and share your stuff. Go ahead.
Okay, so I was going to share my personal setup. Am I the only person in the room recording right now? Like, I see this photo. Perfect, cool.
Yeah, this is a recording OK Meetup, right?
Yes.
Yes. Something I want to do for my conference in June is like everything should be default recording, and then you opt out instead of opt in. So
yeah, absolutely. So what I do is I record all my life constantly, 24/7. I have 2 setups, 2 recorders. And I live in the Netherlands, which allows me to record people without the explicit consent because it's legal in the Netherlands. If you have any private conversation, you are just allowed to record it. You are not allowed to share. So that's cool. And yeah, what I like, my personal setup is pretty simple. This is the recorder. It's running all the time. I have quite a number of use cases for it already, and I also, but the main goal for me is to create a huge data set all my life. 1 year of my life is less than a terabyte of data, or like 1 year of audio is less than a terabyte of data, and we absolutely can afford just saving all this stuff and then mine this data for important insights. For example, I have really interesting and lovely conversations with my friends, and I use it. I just dump them on my audiobook player and just can listen to the best conversations with my friends or on player. It's incredible. But I also talk a lot to myself when I'm alone, and I'm just explaining this future self, the context of my life and how is my life started and what is going on. I also record all my therapy sessions. Well, I record everything, and I'm pretty sure it's something that will help me to align AI with myself. If I will have this huge data set, I call this ultra-personal alignment because there is this gross alignment problem. But I also want AI to know me really, really well, to understand me in the proper context and how to help me to succeed. And I think this data set I created is really valuable. And all of you who are not recorded right now, I think you should, even if you're not going to use it right now, you'll just have this data. Like, there is no good reason not to have this data. It's a recording OK meetup. I think you should, like, if you have your Apple Watch, just like open audio notes and start recording conversations you have. Like, it's super easy to do. You can just take your phone out of the pocket and just record stuff. Thank you.
To me, that's actually what a meetup should be like, that people bring their stuff and like talk about their passions, what they're working on. It's not a series of prepared talk after talk. But you actually reminded me, I actually hacked on this iOS shortcut where I can just always like press my button and it starts recording anything I have in person. And I've actually done this in meetings. And when I'm done recording, I can click it, it transcribes it, saves the file, and then offers me to do a summary right after. So it's highly recommend it if you want automation that's simple, that doesn't require walking around with this stuff.
I want to share my shortcut as well. So my shortcut is, I wrote some code to do it, but when I press my action button on Apple Watch, it also starts recording, and it listens to what I say and saves it locally. And then when there is internet connection, it sends it to the cloud and transcribes it, and I see it in my Notion as like a list of what's recorded and then transcription next to it, and it works really well. I can do it on the plane. It works.
Wow. Okay. Nice. So I'm definitely gonna. If you want to share that shortcut with the rest of us, I'd love to steal it.
It's really messy, but I do want to do this.
Yeah. Okay.
I want someone to improve this code because I'm working on my staple.
Afterwards. I
yes,
some Apple Watch code for you.
Hey. All right. Awesome.
Feel free to talk to me after this.
Yeah. This is what a meetup's about. Awesome. Okay. So something a little bit more polished. Because I've already seen you do this talk, but this is great. So do you want to hold the mic or?
I think the audio should come out as well when we get to the demo, but yeah, so hey everybody, Damien Murphy. I work as an applied engineer at Deepgram. So yeah, what an applied engineer is it's basically a customer focused engineer, right? So we work directly with startups like yourselves, and we help you build voice enabled apps. What I'm going to show you today is really around how to build essentially what you saw with Vappy, but using open source software, right? So being able to make something like Vappy yourself. Some of the main considerations when you're building a real-time voice bot is performance, accuracy, and cost, and being able to scale. You want everything with a real-time voice bot, like when you called it, right? You had sub-second response time. So being able to get that sub-second response time is super important, right? So essentially, if you go beyond, say, 1.52 seconds, a lot of people will actually say something again, right? They think that the person is no longer there on the other end. And you need to do that for speech to text, the language model, and the text to speech. And then on the accuracy, right? So you want to be able to understand what the person says, regardless of their accent. And you want to be able to do that in multiple languages as well. And then on the TTS side, really being able to be human-like, right? That's the big challenge. And then cost and scale. So, you can build a lot of this stuff with, off-the-shelf open source software, and, probably the text-to-speech stuff won't be fast enough, or the transcription won't be fast enough. But you can actually do a lot of this with managed solutions as well. And I'll go into the unit economics towards the end. So yeah, this is the basic setup. So you have a browser, and that's going to send audio. Obviously, you need to interact with the browser to capture audio. That's one of the requirements for security reasons. So you'll see a lot of these demos, you have to click a button to actually initiate the speech. The voice bot server, it's actually repeated here multiple times just to kind of simplify things. But you can imagine this is a back and forth, right? You're doing browser to the voice bot server to get the audio, and then the voice bot server sending that off. And the goal here is to get sub-second latency. So we have around 200 millisecond latency. We can get that down a lot lower if you host yourself. So that's actually what Vapi does. They host their own GPUs running our software. And you can crank up, the unit economics. So you can say, hey, you know what? Instead of doing it at this rate, I want to do it 5x. So you can get that 200 milliseconds down to the 50 milliseconds at the cost of extra GPU compute. And then GPD 3.5 Turbo or 4, you probably get 400, maybe 600 milliseconds of latency in their hosted API. If you go into Azure and you use their services, you can get that down a lot lower. And then on the text-to-speech side, I'm going to show you using Deepgram's text-to-speech. There's a lot of other text-to-speech providers out there. What we try to do is have low latency, human-like at a really good price point. You can get extremely human-like at about 40x the price. But that's just something to keep in mind. All right, demo time. We have 2 tabs open here. Okay, so hopefully this audio will play.
Good evening. How can Deepgram or
text-to-speech
meet the specific needs of your projects?
Modify the sound output.
You're using my the sound output.
Let's try it now.
Okay, sorry, it's gonna be loud. We can't control it.
I think I may have blown the speakers.
Did you blow the speakers? Try to tell us something.
Yeah, I can use just the laptop. Yeah. Okay, let me do that.
Yeah, so turn off the. Yeah.
Alrighty.
Okay, let's see if it works.
Good evening. Planning to integrate Deepgrams or a text-to-speech into your workflow? Let's discuss how to get started.
Yeah, I want to talk about something else today. I'm actually at an AWS hackerspace for a meetup with personal AI.
Sounds like a cool meetup. What's on your mind today? Feel free to share your thoughts or questions.
Yeah, could you give me something funny to show in my demo?
Absolutely. How about a joke or a lighthearted anecdote to break the ice during your demo? Laughter always helps.
Yeah, that'd be great.
How about this one? Why did the computer go to the doctor? Because
Wait,
it
hang
had
on there a second.
a virus. Smile, feel free to share that. How about this one? Why did the computer go to the doctor? Because it had a virus. Smile, feel free to share that with your audience for a good chuckle. Take your time.
Yeah, so you can see there, right? It's pretty low latency. Oh, sorry, it's pretty low latency. And thanks. And if you want to get the source code, it's all open source, right? So you can just grab that whole repo. You can build your own voice bot. And if you want to hook it up to like a telephony system, we have that all available in sample code as well. So you can hook it up to a Twilio, buy a number, do those sorts of things. So let's just jump back into the presentation. Oh yeah, so the different components, right? So the speech to text, that's going to be super low latency, right? If you don't get that accurate, you're going to get the wrong answer from the LLM. And this is the code that you can use. So we have SDKs, Python, Go, Ruby, .NET, and you can essentially use all of those. This is actually a Node.js SDK. And it's very simple to set up, right? You literally just import it, drop in your API key, and you can listen to those events. So we'll give you back all the text that was actually spoken while it's being spoken, and you just need to send us the raw audio packets. And then on the GPD side, so you can swap this out with Claude. We actually have a fork of that repo that uses Claude as well. Claude Haiku is surprisingly good. So if cost is something we want to get down, that's definitely an option. But some of our customers will actually run their own like Llama 2 model, super close to the GPUs that are running the speech to text and text to speech. And that just removes all the network latency out of the equation. Yeah, so here's a simple example of how you would consume that. I'm sure you're all pretty familiar with the OpenAI API. And that will basically give you streaming. That's one of the really important things here is you want time to first token as low as possible. The reason for that is if you wait till the last token, you're going to increase that latency. And then on the last bit, this is the text to speech part. It's a little more tricky, right? You've got to deal with audio streams, and you're going to want to stream the audio as soon as you get it so that you can actually start playing it the moment, the first byte is ready. And that, like, again, with the LLM, if you wait till the last token, if you wait till the last byte of your audio stream, you're going to incur that bandwidth delay. So yeah, if anybody wants the open source repo, go ahead and scan that. Yeah, have a question there?
Yeah, it's a really cool demo. The latency is great. Like, what do you think the next frontiers are? Like, I mean, you had interruptions, right? What about, like, can it proactively interrupt you? Like, based on maybe it knows what you're trying to say, like a human would just cut you off, or like back channeling or overlapping speech, and all the more getting more towards human level kind of dialogue.
Yeah. So the question was, could the AI interrupt the person? And that's definitely possible. I don't think that would happen necessarily at the AI model level. I think that would just be business logic. So you'll get everything that's spoken as it's spoken. So like if you were like, you know what, I think I know what you're going to say, you could preemptively do it. And I have seen some demos where that's a trick that they use to actually lower the latency, is to predict what you're about to say. Right, so then you can fire off an early call to the LLM.
This guy built that.
Yeah,
Yeah,
that was
the demo, open repo, and everything. The interrupting cat demo.
Oh,
yeah. Very cool. Yeah, and the cost of a lot of these LLM things is a big challenge as well. So like if you're doing, constantly sending it to an LLM to achieve these use cases, your cost per minute might go up to like 30 cents. So in this demo here, and these are all like kind of list prices, you can get these prices down with volume. So like if you just signed up today, these are the sorts of prices that you would pay. And just to give you an idea, right, GPT 3.5 Turbo has dropped in price dramatically over time. So Claude Haiku is even a fraction of this as well. And then on the text to speech side, doing something like this with an 11 Labs would be about maybe $1.20. Just to give you an idea of comparison. So you can do a 5-minute call here for about 6.5 cents. If you're doing millions of hours of calls, that price can definitely come down. So changing that then to be like a real-time callable voice bot like you saw with the VAPI demo, you're essentially just swapping out the browser for this telephony service, right? So Twilio has about 100 millisecond latency to give you the audio when you get called. And then you're just sending it through that same system and then just back to the telephony provider. So if you sign up today, you get $200 in free credits. For post-call transcription, that's about 750 hours. For real-time, that's probably about 500 hours of real-time transcription. So it's a pretty big freebie there. So if anybody wants it, and that's it. Any questions? Yeah, go ahead.
Just in terms of achieving real-time performance, GPT 3.5 versus 4, like how do you?
Yeah, 4 is going to be a lot slower, especially if you're using their hosted API endpoint. You're going to see massive like second fluctuations in their hosted endpoint. If you go on to like Azure and you use their service, you're paying more, but you're getting much better latency. So you could deploy all of this on Azure next to GPT-4, and that's going to give you the sort of latency that you saw in the VAPI demo. The demo I get actually is using all hosted APIs, so there's no like on-prem kind of setup there.
We have Ethan, Nick, and then I think Harrison just walked in. So I'll just warm you guys up. But thanks to Damien. Damien only signed up to speak today, which is very classic Meetup strategy. Yeah, I think so. We don't have a screen for this. Do we have a screen? Okay, you can share your screen.
I can share my. All right, so the I'm afraid the audio might be like shattering your eardrums, so I might have to cut it off. But we can try. You said it was okay. It's
Yeah, I mean.
Okay.
Better than nothing.
You do the from the laptop, no?
No, there's no laptop.
Yeah, sorry.
So maybe from the start,
like,
what did you work on? Why?
Yeah, sure. So I think actually, like, it feels good to be here because I feel like I'm with my people. Like, you pretty much summed up the philosophy. Like, what can AI do for you if it has your whole life as context and you kind of experiences your life as you do? Like, wouldn't it be way better? Understands you, it has all your context. So that's kind of, I think a lot of us here have the same idea, and so that's what I've been working on for it's about November. when Lava came out. So first started working on like the visual component. It's not just audio. You wanted to see what you see. But it's a lot more challenging to get a form factor with continuous video capture. So built a really, really small but simple device that's actually easy to use.
Pull it up.
Where?
I don't know. If you pull it up for them.
Yeah, I mean, you guys can check it out after the talk. But I think there's a lot of advantages to not having to have an extra piece of hardware to carry around. But at least we try and make it as small and as light as possible. You only have to charge it every couple days. But there's also other subtle reasons why it's good to have an external piece of hardware, which I can show you in a minute. But so yeah, this captures all the time, and in fact, I can show you here in the app. So you can see that we call it the V. It's got the battery level here. But here you can see all the conversations I've had, and this is actually an ongoing conversation. So you can see, we know where I am, and transcript in real time. We do a bunch of different pipelines. So like after the conversation is over, we'll run it through a larger model, and then do the speaker verification so it knows it's me, which is important so it can understand what I'm saying versus other people in the room. Actually, conversation endpointing, and the Deepgram person probably knows, that, like, even just utterance level endpointing is complicated and hard. Like, when am I stopping talking? Or am I going to keep talking and I just pause for a second? That's hard. But then conversation endpointing, like, when is this a distinct conversation versus another, is even harder. But that's important because you don't want just one block of like dialogue for your whole day. It's much more useful if you can segment it into distinct kind of semantic conversations. So that involves not only voice activity detection, but things like signals around your location and even the topics that you were talking about, like at the LLM level. So it's very difficult. There's still a lot of work to do, but it does work. So like in the end result, I will get a summary generated, some takeaways. It's kind of summary of the atmosphere. Then like, oops, didn't mean to click on the link. Then from the major topics, I'll find some links, and then you still have the raw transcript. So that's like kind of the foundation layer, is to like have something that does the continuous capture, does the basic level of processing, but that's just kind of the base layer. I can query against like the whole context of everything it knows about me. I'm just trying to type with one hand. So
this one helps.
So I think this is, I was talking to my developer a few days ago. So here we have, it's through retrieval on all of my conversations. This is a conversation I was last talking about, and it will even cite the source. So I can just jump to the actual conversation, which is a few days ago or a week ago or something. And so here we were debugging some web view issues. So that's just kind of like the basic memory recall use case. I just have maybe one or two more, then I'll turn it back over. So again, that's all kind of the base layer, but like the real, I think everybody here believes like the real future will be using all of this context so that AI can be more proactive, can be more autonomous, because it doesn't need to come to ask you everything. Like if you had to meet your coworkers every day and they like it's a blank slate, it's like way less productive than if they have the whole history. So there's a voice component to it, and this is, I'm a little nervous because we're just blowing everybody's eardrums out, but we can try.
Sure.
So we're using hot words here, which I don't believe is the best paradigm, but for now, we have some other ideas, but for now, similar to Alexa or Siri, I can basically inform my AI that I'm giving it a command that it should respond to in voice. So I will just, Scarlett, can you hear me?
Yes, I can receive and understand your messages. How can I assist you today?
Okay, that's frightening. I will just now do one example. So like, you have the ability to interact with the internet. Your AI should. So I can have it go do actions for me using any app. So I'll just do a very simple example. Scarlett, send a message to Maria on WhatsApp saying hello.
One sec, I'm on it. Starting a new agent to send WhatsApp message to Maria.
So now this is on my personal WhatsApp account. Maria's right here. She can verify that she receives it.
Yeah, I received that.
Message hello sent to Maria on WhatsApp.
Yeah. So maybe one more, and then I'll let you guys go. So like that's just opening one app and doing something, but can it do multiple apps and have a working memory to remember between app context? So Scarlett, find a good taco restaurant in Pacific Heights and send it to Maria.
One sec, I'm on it. Starting a new agent to send taco restaurant details to Maria.
So it's open Google Maps. It's going to try and find a taco restaurant. Hopefully remember once it does. And then send it to Maria, which it learned that I implicitly meant WhatsApp, right? Hopefully, because it picked up that I talked to Maria on WhatsApp. So going to WhatsApp, pasting the link, send it.
The details of Taco Bar, a well-rated taco restaurant in Pacific Heights, San Francisco, have been successfully sent to Maria on WhatsApp.
Yeah, so that's basically it.
Yeah, that's a great demo. There's got to be some questions. So actually, this is some hands up. You're not going away.
Okay.
It's open source, right?
Components are open source. So there's a history. You know, Adam's here, great. Nick, some really great people in the open source space here. We open sourced a lot. I really learned a lot about open. You know, I've done some minor open source projects myself. You know, mostly I'm just a contributor. But trying to run and launch one was kind of a new experience for me, and I learned that like we did not make the developer experience very good. It was very complicated, like because we were using like local Whisper, local models, and like getting it to work on CUDA, Mac, Windows. We didn't do a good job, so it was very difficult for people to get started. And so I was a little disappointed with the uptake, you know, and they're much better projects that are way easier to use. So really been focused now on just trying to focus on figuring out what the right use cases are and what the right experiences are going to be. And it was like really difficult to try and fit everything into an open source project that would be actually used. So yeah, you can see the repo, and I'd recommend Adam's and Nick's too. But we'll definitely be contributing a lot back more to open source.
Is it OWL or B?
OWL is the open source, the repo.
Yeah, okay.
And you should, I'll plug Adam's Adios and Nick's repo. They can send out the, I don't know what the actual GitHubs are called, but they're easy to find. But yeah, he's going to talk, so you can show. Okay. Yeah.
Can you talk about the hardware?
Sure, yeah.
But tell us more about it.
This is like V1. So we have another like V1.1, which is actually even about 25% smaller, and way better charging situation in terms of wireless charging. So like get the size down. But the real thing we're most excited about is like the next version with Vision. Like I say, Vision's really hard. I don't know of any device that can do all-day capture of like sending video. There's like a ton of challenges around power and also bandwidth. But we have some really kind of novel ideas about it. It's Bluetooth Low Energy, which I mean I'm sure you've seen other ones that operate that way, and that has a lot of advantages. We also have one that's LTE, and so there's like LTE-M. There's like a low power subset of LTE. It's only like 2 megabits, but it's way more power efficient. I think Humane and Rabbit are both LTE and Wi-Fi, but to get like a wearable, you really need Bluetooth.
Just a quick question. Saw the part of the interface where it had was that a streaming from iPhone?
It's like an emulated cloud.
browser.
Is that picture in picture? How are you doing the portion of the interface where you have the Google Maps up in the left corner?
That's on the cloud, so we were streaming that as feedback. I think the ultimate goal is that disappears entirely, right? That's actually mainly for the demo to like show that it's real and that it's working. But like, I think ideally, like, it should be totally transparent that you have like a personal AI. It can do whatever it needs to do, and it will just give you updates on if it needs more info or its status. But like, it's kind of just an interim solution until we have, I guess. So sorry.
No.
Yes, it is.
Okay, last question, and then we have to move on.
Okay, yeah. I also I think I've been experimenting with this app, and you have like a pocket here.
Yeah, I just put it in my pocket.
What I wanted to say about vision is that like I tried to experiment with capturing vision, and like the best solution so far I found is like to buy a cheaper Android smartphone and in your pocket here, like camera outwards. It's incredible. It has internet connection.
Good battery.
Good battery. It's incredible. And it's extremely cheap, and it's wearable. Like you have this pocket.
Yeah, I've had whole demos of doing that because also it doesn't put people off as much.
Yes, and no one even thinks you.
Nobody ever said anything.
Yes, you just have a.
But I do think in privacy sense, maybe slightly different than you. I do want people to understand, but like it was interesting that her style basically her style but nobody thinks twice.
It's a different thing. You can just write on it. It's like I'm recording it. I'm just saying the convenience of not working on the hardware. You can just take the off the shelf hardware.
But you do need a front pocket. So maybe there'll be new AI fashion where it's like these are my phone pockets.
Okay, give it up for him. That was awesome. You're up for fair. I mean, everyone I think will be sticking around, so you can obviously go up to him and get more insight. Awesome.
All right. Hey, everyone. 1 sec. Oh, yeah, it's not connected. Now it is. Nice. So where do I even start? Unfortunately, I was kind of not supposed to be here because I'm organizing a brain-computer interface hackathon tomorrow, and I had to like somehow get 50 headsets, which is why there will be no presentation, but I will still try to be useful to you as possible. This is the hackathon I was telling about right now. We have like lots of people. There will be people from Neuralink. We'll have like 50 different BCI headsets and so on. So if you're interested in like BCI stuff, etc., and if you want to attend the hackathon, scan this QR code and mention that you have been here and oh yeah, my bad, sorry. And you might get much more chances to be accepted. Because we have like 50% rate. We try not to accept people who don't have experience. Anyways, so yeah, what I will try to help with, I honestly really love open source, and I believe like all this stuff should be open source, which is why now on this short demo, I will just show you all current open source projects, and I will try to highlight most important things you need to know about them. And I'll probably first start with OWL, which you have just seen by Ethan. So he started that. I think he was like one of the first people who started like open sourcing any kind of wearables. Probably Adam actually was before, but you announced first, so I remember that. But yeah. Anyways, so yeah, this is his repo. You can like check it out. I think I have a QR code here opened as well. If not, just give me a sec. I will just generate it quickly for you. All right. Should be, yeah, just scan this QR code and you can just access his repository. Yeah, so this is Ethan's. Then there is another one, which in my opinion, well, it's definitely the biggest one. It's by the guy who's sitting right there, Adam. I truly believe that Adam is like the guy who started all open source hardware movement. So at least I started doing everything because of Adam. So thank you for that. And they have a lot of traction here, 2.6 thousand stars. And if you want to kind of like ramp up your way into open source like wearables of any kind, I suggest to start with this repository. It's probably the biggest one you'll be able to find right now. And the QR code you can scan, I think this one. Yeah, just like feel free to scan.
I'll send it.
Yeah, cool. Awesome. So They use, I think, Raspberry Pi, also use PE32, which is kind of technical. You probably don't need this information. But anyways, yeah. And now who I am, like a little bit about myself as well, some marketing. So my story starts very recently, maybe 2 months ago after I saw Ethan's and Adam's launch of like their open source hardware stuff. And I launched my own. It all started with basically cease and desist from Humane. And we launched like just for fun, honestly, Humane. The idea here was like you take a picture and you scan the person's face, and we search the entire internet and we find the person's profile, like and send it to you via like I don't know, like via notification or on the site and so on. So this is how it looks. Started with that, had a lot of contributors, was a fun project, but not really. I mean, like yeah, we don't really want to bring any harm to human and so on and so forth. Just fun stuff. So after that, we did QR for this. I think we will also send, right? Like cool. Okay, another one I will promote here a little bit is this one. This we launched literally like last week. This is pretty much what Adam and Ethan have done, with the only difference that we use right now the lowest power chip. I think Ethan also uses that. I just try to like as soon as possible to let everyone know that like I think it's probably the best opportunity you can currently find on the market. It's called Friend. You can check it out. This is how it looks. Or actually I have it with me. I was supposed to actually show you like the live demo as well, but we just did a very cool update where we made it work with Android, by the way. So it's iOS and Android right now. And also we updated the quality of speech literally 3 hours ago and made it like 5 times better. So when we launched, I'll be honest, it was like completely horrible. And now it's like 5 times better. It's amazing. And I'm really excited by that. I would want to show you the video, but I know that it's like, you will not want to have your ears, you know, like. Oh, yeah, really? Oh, nice. Okay, let's try. Anyways, yeah, this is the chip that is being used inside of that wearable. And it works pretty much the same as what Ethan has. Wait.
Giving the permissions.
Oh, it doesn't work, right?
Next, scan for the device.
1 sec. Wait. Let me figure out this. Which one? Kristen?
Yeah.
Oh.
You can go back a little bit.
Okay. Let's try. Oh, nice. Okay, cool.
So
awesome.
Started giving the permissions here, and hit next, and scan for the devices here, and then select the device, and that should just connect. Okay, I think we can just start speaking. Yeah, so pretty much testing this for the first time, and let's see if it's able to transcribe what I'm trying to speak. And yeah, pretty much waiting for the first 20-30 seconds to finish, and for it to return us the output of the speech from the OpenAI whisper endpoint. And it says if it's checking, yeah, there we go. And yeah, it says.
Yeah, so as you have seen, it recorded the speech on the lowest power chip probably ever right now accessible in the market. And I'm very excited that we actually made it work, because it was very, very hard. It took like a lot of time. Anyways, that's pretty much it, I guess. I don't really have anything else for you to show. This is the final QR code. I know you will have all the links, but this one I really, really advise you to scan, because it has basically the collection of like all links in one place. So yeah, that's pretty much it. Use open source. I think it's cool. And let's try to build cool stuff together. That's pretty much it. Thank you.
Any questions? Did your wearable record all that?
No, because
Harrison, you can tell actually.
Yeah.
You're not recording right now.
No. I'm not recording because we launched the update like 4 hours ago, and I wanted to bring it here, so I broke my thing, and now it's like all broken, unfortunately. But anyways, any questions? Cool. Yeah.
What do you think the biggest next challenge is?
Biggest next challenges?
Yeah, I definitely agree with you that the biggest challenge is like adding video and images and so on. It's like very hard as hell. And I think to make software useful as well is very, very hard. Yeah, we can all do maybe like recording from the device and like attach maybe some battery and so on. But like how to make it actually like sexy, that's hard. Like how to make it, do actions, how to make it remember everything and so on and so forth. That's the biggest challenge. So yeah, but I agree with everything you said.
I would add to that. I think the biggest challenge is making people want to wear it.
Oh yeah.
And I'm not the tech bros or girls of Silicon Valley.
Yeah, Adam, the guy who created the biggest open source thing, he said that the biggest challenge is to make people want it, basically, right? I mean, yes. So that's one of his suggestions. Yeah, go on.
What's been the challenge in reducing latency?
What's been the challenge of reducing latency? Honestly, it was just like software issue because like this chip is like not that widely used. There is not so much documentation, not so many projects, and so on. So just like a matter of like trying a lot of things. And also, it doesn't have huge onboard memory. So like, how do you store very quality memory on a very small, very quality audio on a small memory chip, and then send it to phones, like stream it basically nonstop? That was pretty hard. But we solved it like 5 hours ago, and that's pretty much it. So, yeah, go on.
How did you improve the quality of voice by
we just made it work. Like we used, we had 4,000. Pretty technical. I don't know if you want this, but anyways, we used 4,000 hertz like quality. It was like super bad because the memory was too small. And now we just found a way to like compress it and improve it to like 16,000, which is like pretty great, which you have heard on the video. So it can like recognize pretty much anything, even like multiple people speaking, even if you will be there and the device will be here. So yeah. Anything else?
I think we can leave
the last one. Go on. How far the device can detect audio, correct? Cool. So good one will be like 2 feet from person to person, like good. If you have maybe like 4 feet from each other, the quality will be 50% accuracy. So yeah. Cool. Thank you all. Go open source.
Cool. So what I want to talk about is a lot less cool than all this hardware stuff. So I feel a little bit out of place. But my name's Harrison, a co-founder of LangChain. We build kind of like developer tools to make it easy to build LLM applications. One of the big parts of LLM applications that we're really excited about is the concept of kind of like memory and personalization. And I think it's really important for personal AI because hopefully these assistants that we're building remember things about us and remember what we're doing and things like that. We do absolutely nothing with hardware. So when we're exploring this, we are not building kind of like hardware devices. So we took a more kind of like software approach. I think one of the use cases where this type of like personalization and memory is really important is in kind of like a journaling app. I think for obvious reasons, when you journal, you expect it to be kind of like a personal experience where you're kind of like sharing your goals and learnings. And I think in a scenario like that, it's really, really important for if there is an interactive experience for the LLM that you're interacting with to really remember a lot of what you're talking about. So this is something we launched, I think, last week. And it's basically a journaling app with some interactive experience, and we're using it as a way to kind of like test out some of the memory functionality that we're working on. So I want to give a quick walkthrough of this, and then maybe just share some high-level thoughts on memory for LLM systems in general. So the UX for this that we decided on was you would open up kind of like a new journal, and then you'd basically write a journal entry. And I think this is kind of like a little cheat mode as well, because I think this will encourage people to say more interesting things. So I think if you're just taking like a regular chatbot, there's a lot of like, hey, hi, what's up? Things like that. And I don't think that's actually interesting to try to like remember things about. I think it's more interesting if you talk about personal things. And so let me try this out. I'm giving the talk right now. And then I can submit this. And then the UX that we have is that a little chat with a companion will open up. Okay, so yeah, so right before this, I told it that I was about to give a chat about a journaling app, and so it kind of like remembered that I was going to do all that. Is there a particular part I'm most excited to share? The memory bit. I don't know. So this actually worked on the first try, so I was a bit surprised by that. So that's good. And oh, okay. So how do you plan to tie in your love for sports with the theme of memory during your talk? So before, when I was talking to it, I had mentioned that one of the things that I wanted to talk about was, how a journal app should remember that I like sports. So I guess it remembered that fact as well. Amazing. So I can end the session. So the basic idea there, and again, this is, we're not building this as a real application. We would love to enable other people who are building applications like this. I think the thing that we're interested in is really like, what does memory look like for applications like this? And I think you can see a little bit of that if you click on this memory tab here. We have like a user profile where we basically kind of like show what we learned about a person over time. And then we also have a more like semantic thing as well. So I could search in things like Europe. And I'm going to Europe kind of like after a wedding. I love Italy. And so basically there's a few different forms of memory. If you'll allow me 2 minutes of kind of just theorizing about memory, we're doing a hackathon tomorrow, and maybe some of you are going to that. Swick signed up. I don't know if he's actually going to show up. Very quickly, like how I think memory is really, really interesting. It's also kind of like really vague at a high level. I think like there's some state that you're tracking, and then but how do you update that state and how do you use that state? These are like really kind of like vague things, and there's a bunch of different forms that it could take. Some examples of kind of like, yeah, thanks. Some examples of memory like that a bunch of real apps do right now, like conversational memory is a very simple but obvious form of memory. Like if it remembers the previous message that you sent, like that is like incredibly basic, but I would argue that it can fall into this idea of like, how is it updated? What's the state? How is it combined? Semantic memory is another kind of similar one. Where it's a pretty simple idea. You take all the memory bits, you throw them into a vector store, and then you fetch the most relevant ones. And then I think one of the early types of memory that we had in LangChain was this knowledge graph memory, where you kind of like construct a knowledge graph over time, which is maybe like overly complex for some kind of like use cases, but really interesting to think about. So LangMem, like name TBD, is some of the memory things that we're working on. And we kind of wanted to constrain how we're thinking about memory to make it more tractable. So we're focusing on like chat experiences and chat data. We're primarily focused on like one human to one AI conversations. And we thought that flexibility in defining like memory schemas and instructions was really important. Like one of the things we noticed when talking to a bunch of people was like the exact memory that their bot cared about was different based on their application. If they were building like a SQL bot, that type of memory would be very different from the journaling app, for example. So there's a few different like memory types that we're thinking about. All of these are very like early on. I think one interesting one is like a thread level memory. An example of this would just be like a summary of a conversation. You could then use this. You could extract like follow-up items, and then in the journaling app, you could kind of like follow up with that in the next conversation. We actually might have added that. That might be why it's so good at remembering what I talked about in the previous talk. I forget. Another one is this concept of a user profile. It's basically some JSON schema that you can kind of like update over time. This is one of the newer ones we've added, which is basically like you might want to extract like a list of things. Similarly, like define a schema, extract it, but it's kind of like append only. So an example could be like restaurants that I've mentioned. Like maybe you want to extract the name of the restaurant and what city it's in. If you're kind of like overwriting, if you put that as part of the user profile and you overwrite that every time, that's a bit tedious. So this is like append only. And then we do some stuff with like knowledge triplets as well. And that's kind of like the semantic bit. I think probably the most interesting thing for both of these is maybe like how it's like fetched. So I don't know if people are familiar with the generative agents paper that came out of Stanford last summerish, but I think one of the interesting things they had was this idea of fetching memories, not only based on semanticness, but also based on recency and also based on like importance. And they'd use an LLM to like assign an importance score. And I thought that was really, really novel and enjoyed that a lot. And yeah, that's basically it. So yeah, questions.
Well, yeah. I think you know about all the same things. I think a lot of your approach makes a lot of sense. Same kind of compromises you have to make for simplicity. But like to give it true knowledge, you talk about like the triplets. And, like how do you think that we can get to the point where we can have more of a dense graph rather than just simple propositions about you? Because like our memory works, it's all relational to like to people, to places, and that's actually important information. And so like, do you think we'll be able to figure out a simple way to do that, or is it just going to be too hard?
Yeah, the honest answer is I don't know. I think even today, like if you had that, and I think like there's two things. Like one's like constructing that graph, but then the other one's like using that in generation. And like even today, like for most like RAG situations, if you combine a knowledge graph, it's often not taking advantage of a lot. It's really like there's different ways to put a knowledge graph into RAG, and it's not it's very exploratory there, I'd say. So I'd say like one issue is just even creating that, and then the other one is like using that in RAG. So I think that's like a huge I don't know.
Yeah, we'll see. It's interesting.
Cool stuff on the memory thing. I just had like a couple points. I think no matter which memory option you're using, like let's say you're using like the pen-only memory model versus the knowledge graph one, like eventually that has to be inserted into context, right? Like you're picking the relevant sections, and then there might be like a semantic layer to figure out, okay, which facts should I embed into the context during generation or during the query? But like, I was just curious, like, is there work on defining semantic models that don't leverage like the reasoning of the model, that sort of like, let's say you want to build up like not just memory, but like an understanding of the semantics of the operations, for example, outside of depending on the language model to provide that semantic interpretation on top of whatever memory context you inject.
If I'm understanding correctly, are you asking like, is there a concept of building up a memory about how the language model should do like the generation aside from just inserting it into the prompt?
Yeah, like the memory is just externalizing. It's basically a cache for to like get rid of the token limit and also bring things into more attention by transforming the prompt a little bit and injecting instructions about how to treat bits of memory. I was wondering, like, has there been work done to basically decouple the language processing versus like the actual like operational semantics of using the memory?
Yeah, I'm assuming there's. Yeah, I think like an alternative approach to this, which I think is what you're getting at, is like rather than kind of like creating these strings and putting them into the prompt, you could have some kind of like attention mechanism which would like attend to different parts of previous conversations or something like that. I'm sure I think like, I mean, you could take this to the extreme and basically say like, there's a lot of stuff that can fit into like even like 1 million token context window or a 10 million token context window. And so an alternative strategy could just be like, hey, put everything, all these conversations and all these journals I've ever had into one LLM chat and kind of like let it go from there. And yeah, I'm sure people are working on things like that and doing things like some sort of like captioning to make it easy to kind of like continue that. I don't know of any details, but yeah, I think that's a completely valid, completely alternative kind of like approach. It's also really interesting. I don't think anyone knows how to deal with memory, and so I think all these different approaches are.
I think in a general way, right?
Yeah.
It's hard to introspect what's going on in our own brains.
Questions? Yeah, so when I see these systems, and I guess that's a question pretty much for everyone who presented, right? Like when I think about these systems, I always think, what does 10 years of memory look like? And a lot of the facts that we remember are either not relevant anymore or probably false. So how do you think about like memory?
Yeah, I think there absolutely needs to be some sort of memory decay or some sort of like invalidating previous memories. I think it can come in a few forms. So like with the generative agents kind of like paper, I think they tackled this by having some sort of recency weighting and then also some sort of importance weighting. So like it doesn't matter like, you know, how long ago it was, there's some memories that I should always remember, right? But then otherwise, like, you know, I remember what I had for breakfast this morning. I don't remember what I had for breakfast like 10. And maybe I should, but I don't think that's like important. So yeah, I think like recency weighting and importance weighting are two really interesting things in the generative AI or the generative agents paper. Another really interesting paper with a very different approach is MEMGPT. So MEMGPT uses a language model to like actively kind of like construct memory. So like in the flow of a conversation, like the agent basically will decide whether it should write to like short-term memory or long-term memory. And I think I think it's actually quite a different approach because I think in one you're having the application like actively write to and read from memory, and in the other one, the one that we're building, is more in the background. And I think there's pros and cons to both. But I think with that approach, you could potentially have some like overwriting of memory or yeah.
Cool. One next question.
Last question. Also, that generative agent Smallville paper, amazing. There's like one page. They have like an exponential time decay every day. Stuff is less relevant. Definitely recommend.
Hey Harrison, thank you for the presentation. I just want to ask about, there was a new paper called Raptor, I think, and it feels like it's a really cool approach to memory because sometimes when you want to say something like, who am I, or roast me, it's really hard to do with RAG and these type of approaches, but the Raptor could be a nice way to tackle that. Your opinion on that.
Can you summarize the paper?
I think it's about like doing like partial summarization and in like a free form, and we are trying to experiment with that. And it seems like, but I think you know more about it. I just like found out about a couple of days ago. So
yeah, no. So I think the idea is basically for RAG, you chunk everything into really small chunks, and then cluster them, and then basically hierarchically summarize them. And then when navigating it, you go down to different nodes. I hadn't actually thought of applying it to memory, but that actually makes a ton of sense. So one of the issues that we haven't really tackled is in this journaling app. If you notice in here, there's a bunch of ones that are really similar, right? And so like there's a clear kind of like consolidation or update or something procedure that kind of needs to happen that we haven't built in yet. And so I actually love the idea of doing this kind of like hierarchical summarization and maybe like collapsing a bunch of these into one, and maybe that runs as some sort of background process that you run every, I don't know, you run every day, week, whatever. It collapses them, accounts for recency to account for the issue that was brought up earlier around wanting to like maybe overwrite things. Yeah, I think that's I had not thought of it at all, but I think that's really.
That's kind of like sleeping.
Sorry.
Like when the brain consolidates.
Yeah.
Cool. I think I got it wrapped up here. Thank you so much, Harrison. A round of applause for him. I think that's the real reason why this is not just a hardware-only meetup. It started as a wearables meetup, but then we added real-time voice, and then we added memory, because this is all components of building your personal AI. So we have 15 minutes until we have to clear out of here. Everyone looks like they're sticking around to just chat. If you want to just see the devices and talk to Harrison, go ahead, you may guess. There are like 3 hackathons spawning from this thing, so I'll send all the links on Luma. Thank you very much.
Thank you.